Good morning, friends. Welcome to Water Resources Engineering class. So we are dealing with hydrology. In that hydrology, in today's lecture, we focus on the frequency of rainfall, return period or recurrence interval. What are the steps in frequency analysis? What is the Wilbur formula? Hazen formula, California formula. Then probability distributions of rainfall analysis. Then by Gumbel's method, log Pearson method, and third one is normal or log normal method. Next is applications of rainfall. Next, what is IDF curve and what for we draw the IDF curves, what is the use, and what are the various steps that are to be followed for deriving these IDF curves. So let me talk about the frequency of rainfall. Why we are coming into the frequency of rainfall? The main reason is rainfall is a random variable. It is not something which definitely you can say this is this. It's a random variable. So naturally we use theory of probability for any of the analysis. So for the rainfall analysis, we use theory of probability. Why we use theory of probability? Because rainfall is a random variable. So now what is the use of that? Basically, if you know what is frequency, frequency is how often a given rainfall event occurs. It is the number of times a given magnitude of rainfall may occur in a given period. It is the estimation of the likelihood of a given rainfall in a specified period. The probability of occurrence of a rainfall event is what we call it as frequency. Frequency and probability both we use in a similar way. The probability represents the frequency of rainfall. The probability of occurrence or probability of exceedance, that defines the frequency of rainfall. Then what is the next term that which we require? So when we know what is the frequency of rainfall and it is equal to nothing but the probability of rainfall, actually it is a statistical measure of how often a particular intensity or amount of rainfall occurs over a specified time. Same again and again repeating. And mostly this frequency or this probability is represented by return period. This is what we should know. Always the frequency or the probability of rainfall is represented, this is in terms of return period, or that same thing is also called as recurrence interval. What it is? It is the average time interval. What is the return period? It is the average time interval between rainfall events of a given magnitude, or of course greater also. It is the average time interval between the rainfall events of the same magnitude or greater. The study of probability of occurrence, what for all this? Why we are studying it? The frequency of rainfall, the probability of exceedance of rainfall, the return period, all these three, why you are studying? Why we are studying is we want to estimate the extreme rainfall, and that is of very important actually if you want to find out the design flood. And if you want to design a hydraulic structure, in the case of hydraulic structure, maybe anything, start from the lowest one, culvert, the storm sewers actually, the dams the highest, or any flood control structure, if you take it, in any of these things, you require return period. So that means when we are constructing a structure, we are estimating the life of a structure is 100 years, 200 years or 50 years, like that. Then in that case, what is the likelihood of the flood which is going to come in the next 50 years, in the next 100 years? That we want to estimate first before constructing this structure. If you want to estimate that design flood, then in that case you require the knowledge of the probability of occurrence of a flood or probability of occurrence of a rainfall of higher magnitude, or you require return period. So how many years it takes actually, probably in how many years once it is occurring, that we want to know. So that is why we are studying these things. The main purpose is to predict the extreme rainfall events. Suppose in 100-year rainfall, what is the maximum rainfall? So now based on that data, for future 100 years we predict how much is the maximum rainfall is going to be. Based on that design value of that rainfall, we go for the construction of the hydraulic structure. Why? Because we want to ensure safety first, and at the same time cost efficiency. Without having the knowledge of this return period, frequency and probability, if you just like that take the amount of whatever the flood that comes, so in the 100 years this will not come like this, then safety is at stake. Or if you don't bother and just too much higher you estimate, then cost is escalating. So if you want to ensure the safety and cost efficiency, you must know the frequency analysis and you must know the probability distributions. You must know what is the return period actually. So what is again the recurrence interval? It is the average time interval in years between the occurrence of a rainfall event of the same magnitude or greater than a specified magnitude. An excellent important definition, you all should know it. It is the average time interval in years. That is the first word. Between the occurrence of a rainfall event of the same magnitude or greater than that in a specified period or specified magnitude. And it is reciprocal of frequency. What is T is equal to? It is reciprocal of frequency. T is equal to 1 by frequency, and frequency is nothing but the probability. So therefore return period is equal to, you see, return period is equal to 1 by frequency and it is equal to 1 by probability. So always remember that T is equal to 1 by P or P is equal to 1 by T. This is one of the things. So the return period is defined as T is equal to 1 by P, or the same thing you can write P is equal to 1 by T. So now example, if there is 1% chance of exceeding a particular rainfall, basically, then what we call it as 1% chance. 1% chance means the probability is 1 by 0.01. 1% means 0.01. 1 by 0.01 means 100 years. So such a rainfall value will occur only once in 100 years. That is what you mean by 1% chance. 1% chance of occurrence means actually, that means the return period is equal to 1 divided by the probability 1% is equal to 0.01. So 1 by 0.01 is equal to 100. So in every, it is the possibility is 100, once in 100 years such type of rainfall will occur. That is the meaning. Suppose if I say the probability is only 10%. If the probability 10% means actually, that means T is equal to 1 by 10% is equal to 0.1. 1 by 0.1 is equal to 10 years. So the return period is 10 years. So a 10-year event, that means 10% chance means the same value of rainfall, the same event of rainfall may occur once in 10 years. That is the way which we pronounce. And what are the various steps in the frequency analysis? So the frequency analysis, first one is your first job is to collect the rainfall data. So obtain the rainfall data from the rainfall records. Actually, we have already taken the rainfall record from the rain gauge stations. So naturally, it may be daily, monthly, annual, we take it actually. Now what I need to do is, whatever the data that is available to me, I adjust it in such that actually the highest value will be at the top, and the descending order I arrange. Whatever, for example, I am having 25 years of rainfall data, for example. The 25 years of rainfall data, what I will do it is, so the annual data I got it. For example, 1981, 82, 83, like that I got 25 years data. What I will do, I will not bother about the year. Out of these rainfall values, which is the highest, that I write at the top. I don't bother about the year. So only what I will write is maximum rainfall value will go to the top and the lowest will go to the bottom. Like that I arrange it in the descending order. Now I rank them. The first one is, the highest one is called as rank is equal to 1. Like that I rank actually. If suppose 25 years of data I have taken, naturally the bottom one is rank is 25. The lowest one is 25. The highest one is 1. Like that I arrange. Then I use the Wilbel's formula or Hazen's formula or California formula to calculate what is the return period. So this is the way of calculating return period. So return period calculation is based on, first thing is you collect the annual rainfalls actually. After collecting the annual rainfalls, arrange them in the descending order. Then after arranging in the descending order, note the top one as 1 rank and last one is the last rank actually. Then use the Wilbel's formula or Hazen's formula or California formula and then calculate the return period. That's what I have written. So the Wilbel's formula says that the return period T is equal to M by N plus 1. What is M actually? M is the rank. If it is the highest thing, rank M is equal to 1. If it is the lowest thing, how many rainfall years you have taken, that will be. Like that 1, 2, 3, 4, 5. From the highest to the lowest, that we need to write. What is N? Number of years of data actually. M by N plus 1 will give you, according to Wilbel's formula, the return period. Then naturally you plot the frequency curve. How to plot the frequency curve? Take the semilog curve, semilog sheet. Take the semilog sheet. On the semilog sheet actually, it is a semilog sheet. On the semilog sheet, x-axis you take actually the return period. That is the first thing. X-axis you take the return period and y-axis is the annual rainfall. Annual rainfall. You take it, then naturally you get a straight line. So that is how you get it. Once you plot this for any thing actually rainfall, you can get what is the return period straight away. So with the data whatever is available, this if suppose somebody asks I want 100 years return 100 years return period, then according to this curve, naturally 100 years return period, what is the rainfall value, you can straight away note from this. So the other formula, which is I mentioned it as California method and at the same time Hazen formula, both also I have written here for your understanding sake. Once again, frequency is nothing but the probability. The frequency is expressed as it is 100 into probability. Once this is over, the first topic is how to find out the recurrence interval. So we have 3 methods for finding out the recurrence interval. Once recurrence interval is found, take return period on x-axis on the semilog sheet and on the y-axis basically rainfall, draw the graph and it is a straight line. So that is what we call it as the frequency curve. That is over. Now I am going a little bit deep actually in the sense what is the probability distributions of rainfall, how the rainfall distribution you can make it actually. So in order to make the rainfall distributions, we have 3 methods. One is the Gumbel's method, second one is log Pearson type 3 and it is actually US mainly they are using this log Pearson third, and normal or log distribution is when it is uniformly distributed, that can be used. But we are using right now only Gumbel's distribution. So we take it from our end only Gumbel's distribution. That is the only thing which I take it. What is Gumbel's distribution? Statistical analysis. It's only purely statistical, only expectations, only visualizing into the future actually. So rainfall value for any return period. So this x is nothing but this is the rainfall value for t means what indicates for a return period of t years. That is, so this we want to calculate. So what is the rainfall value for a given return period? That is what we want. For a given return period, what is the rainfall value? That you need to find out. How I find out? So from the rainfall data, whatever I have, I find the mean of it. Mean, you know how you find out. So x bar is nothing but actually sigma x divided by x1, x2, x3, x is equal to 1 to n divided by n, number of years of data. So using that, you can find out x bar. Then k is some frequency factor. It depends on so many factors. Right now, our interest is somebody should give us k value in order to find out what is the rainfall value for a given recurrence interval. Then the sigma is the standard deviation. Sigma is the standard deviation. So once you find out what is x bar, so it is nothing but x1 minus x bar whole square plus x2 minus x bar whole square, like that all sum divided by n minus 1. If you put it, then you are going to get the standard deviation. So already these two, how to calculate, we have given in the previous lectures. So x bar we can calculate with the given data, sigma standard deviation we can calculate with the given data, knowing x bar, sigma, and this k value should be given, which is a frequency factor actually. And then now for any given return period, what is the rainfall value we can find out. That is the next thing. So once that is found out, actually, now I will put the sequence of the steps. Collect the annual maximum rainfall data, right? Rank them in the order actually. So when you rank them, naturally you can get the return periods. After getting the return periods, actually you get the probability distribution. Once that is done, estimate the rainfall for a selected duration. For any selected thing, you can find out this. So this is the frequency analysis. What for? What for the frequency analysis? For flood control purposes you need it, for stormwater drainage systems you need it, and drain culverts we need it, then we need risk assessments we need it, and water resources management we require this basically frequency analysis. So now let me go into what is a IDF curve, which is very important for you. Write short notes on IDF curves actually. I means what? I means intensity. D means duration. F means frequency. The moment I say F means F is the frequency, F is the probability, and nothing but actually in turn related to return period. 1 by probability or 1 by frequency is nothing but the return period. So that is the thing. Even though I write IDF, it is not the frequency I put it on the graph. It is definitely the return period. And frequency is equal to probability, and it is 1 by basically t. So therefore t is equal to 1 by frequency or 1 by probability. Now what is the definition of an IDF curve? IDF curve represents the relationship between the rainfall and duration. Not rainfall, sorry, intensity of rainfall. Please remember, there is a big gap between rainfall and intensity. Rainfall is in mm, whereas intensity of rainfall is mm per hour. Per hour, how much is the rainfall? Whereas the rainfall means mm means it is hour, day, or annual, whatever it is. We don't specify it actually. It is the total rainfall depth, right? It can be anything. It can be per hour, it can be per day, or per year also. But intensity means you need to mention the time. It is per hour, per minute, per day. Like that you need to specify. So it is the relationship between the intensity and duration. Duration means the time of elapse of the rainfall, and frequency. I already told frequency. In turn, I write it as in terms of return period. Right? Now what for all you are doing, IDF curves are what for they are meant to estimate the maximum rainfall intensity. That is the purpose. The purpose of IDF curve is to estimate the maximum rainfall intensity for a given duration and return period. If return to 100 years, for example, return period, duration is 1 day duration. If I say, what is the maximum rainfall intensity? If you want to estimate, you require IDF curve. So x-axis is duration. It can be log scale or linear. If you take log scale, it will be straight line, or if you take a linear graph, general linear graph, then it will be a curve actually. Then y-axis is rainfall intensity per hour. Then separate curves for each return period. For each of the return period, then naturally we will get a one curve actually. So that curve, the intensity, what is that intensity, whatever we are writing, intensity of rainfall, that can be, whatever that curve is there, that can be statistically given in the form of an empirical equation, and this is the empirical equation. This empirical equation is for basically for what you call it as rainfall intensity. From where we have drawn it is from the curve only. Why we have giving that is, in the exams it may not be possible always to give you the IDF curve and then estimate. So that is why we should be able to know from this also. Using this equation we can found very simple equation. What is intensity of rainfall is equal to some K into T is the return period, and what is this K? K is an empirical constant. Please remember, K is an empirical constant actually. What is T? T is the return period. What is N? This is the exponent of the basic relation between these two. It is an exponent of return period. Then actually what is D? That is our main intention, the duration of rainfall. Then what is this D? This is some adjustment which we are making, the adjustment constant which for the duration. Why this adjustment constant is required is probably in terms of if for example that D becomes 0, then it becomes I becomes infinity. So that is why, to avoid such type of things, this is adjustment constant which will be near 0. It is not 0, it will be near 0 actually. So that should be, otherwise it is not required at all. That is the things. Then fine is what is M is this exponent of this duration. N and M are exponents of the return period and duration, whereas K is the empirical constant. Then how to develop the IDF curves. First is collection of data. Any of these curves, collection of data. What data? It is rainfall data. Right? From where you can collect? From the rain gauges which are being collected, that will be at the meteorological stations. You can go to the meteorological station of any state or any district. You can collect complete rainfall data from there. What is the maximum rainfall depths of for various duration? You, from that data, you take it out and record it. Then frequency analysis. Frequency analysis you can do it by Gumbel's method. And by using Wilbur formula or California or Hazen's formula, you can find out what is the return periods also. So this is the frequency analysis. Then calculate the rainfall intensity. How the rainfall intensity is calculated? Just now we have studied I is equal to some K into T to the power of N by D plus D whole to the power of M, where N and M are exponents of return period and durations. K is the constant, an empirical constant, which depends on the climatic factors of that particular place whichever we are studying. Then plot the intensity versus duration for each return period. Please remember, for each of the return periods, you plot a graph between the duration on x-axis, intensity on y-axis actually. Just for your understanding sake, now I have seen, so this is the duration I have given to you. Then what is the depth? For a return period of, this is the return period, this is the return period, this is the return period. For a return period of 2 years, 5 years, 10 years, 25 years, 50 years, what is the depth of rainfall I have given here? The depth of rainfall means if it is 2 years return period means that rainfall may occur once in 2 years. That is the basic thing that you should remember. So these values we have given. Naturally, convert depth to intensity, rainfall depth by duration. If you put it, automatically you will get the intensity. I am not going into the formula also right now. I will show with the formula in the next problem. Then actually we have drawn the curves. See, for example, return period of 2 years. Now this is the graph. So that means intensity versus duration we have plotted. That means the rainfall depth for a return period of 2 years I have taken. I have calculated intensity. That intensity is equal to rainfall depth by duration. I have put it. From there I got it and then I have plotted it. Now you see how the curves are actually, they're all basically what you exponentially decreasing. Am I right? It is exponentially decreasing. All the things you can see. Similarly, these are all the for other return period. For each of the return periods, there will be one IDF basically. That you should remember actually. Now I told it the second one also I will show it for you. So 10 years historical maximum rainfall data I have taken actually. So how to calculate mean and standard deviation? Just now I told I will show you also how to calculate. Then estimate the rainfall distribution for 10 years return period by Gumbel's distribution. Then use IDF formula to calculate the intensity of thing and plot the IDF. This is the thing. All in one set of problem I am showing it to you. See what is the data I have collected. 1 hour maximum rainfall in all these years. 2015 to 24. 1 hour maximum rainfall. How much it is? So 38 mm, 42 mm, 35 mm and so on up to 52. How to calculate mean and D? The mean can be calculated. It is sigma x by n, right? Sigma x by n you do it. So then you got this answer. So all this divided by how many years it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all this divided by 10 will give you this result. Then how to calculate standard deviation? Sigma of x minus x bar whole square by n minus 1. N minus 1 means 9. So if you do it, you get this. So this is how to calculate mean and standard deviation, right? Now next, for 10 years of return period, how to find out the rainfall. So this is the thing. T is here how many? 10 years. And this is x is basically the rainfall. So x bar just now we have calculated. Sigma also just now we have calculated. This KT calculation, let us not bother about this. We will come at a later stage when I am taking up the gate classes, I will explain. But right now KT is something which will be given to you. So xt is equal to x bar I calculated already. Sigma we calculated already. So it is the rainfall value for a return period of 10 years that can be estimated. That is one thing. That is the first, the distributions, Gumbel distribution, how we have used it. Then afterwards, convert the rainfall depth into intensities using IDF equation. So this IDF equation just now we did kt to the power of n by d plus d whole to the power of m. So k value they will give, n value that fellow should give, and m value also that should give. So k, m, n. Mn are the exponents, k is the empirical constant, and d is, I mentioned it as some time you can choose it, but it should be very, very less, nearer to 0. So we have taken d is equal to 10 minutes, like that I have taken. So now total return period is 10 years. How to calculate? I is equal to k value is 90 into return period is how much? 10 years return period to the power of n value he has given 0.2 divided by d is the duration, and d plus 10 is small d we have taken to the power of m is equal to 0.75. So this is the final thing, that this equation is converted into like this actually with the empirical constants and exponents. Now I will use it. So what is d? They have given it as 5 minutes, 10 minutes, 15 minutes, 30, 60, 120. Now what is d plus 10? Because d plus d is equal to, so d is 10, so we added. So d plus 10 to the power of 0.75. So these values I have calculated. Once that is done, actually the answer is these are the things. So these are the intensities. Once these intensities are obtained, then I have taken intensities and duration. So this is, and this particular curve is exponentially decreasing. What is the return period of this curve? The return period is, already we have taken 10 years. So t is equal to 10 years, 1 graph. Like that, any number of return periods you can take it and plot it actually. So after that, so right now what are the things we explained? First one is the frequency analysis. In the frequency analysis, what is recurrence interval? How to calculate recurrence interval I mentioned. Right? So then after calculation of the recurrence interval, then how to find out basically what you call it as the, for the frequency analysis, what is the return period calculation methods? You can use the Wilbel's formula or Hazen's formula or California formula, and from that you can find out what is the return periods. That is first part. Then frequency graph I mentioned. Close it. Then second part, what I have taken, how to write that equation probability distribution. For that I have given Gumbel's formula. From the Gumbel's formula, what we can find out, what is the rainfall value for any return period, whatever you mention. For that I can find out the rainfall value. That is the Gumbel's distribution. Once that Gumbel's distribution is obtained, then how to calculate intensities. So for the intensities also I have given one empirical equation. From that, after getting the intensities, take actual and x-axis duration and on y-axis the intensity. For a given return period, you can plot a curve, and that is called as IDF curve. For different return periods, you can plot different curves. So that completes IDF curves also. Then I am going into a little bit deeper into this chapter, and in the sense that this is very, very important for any competitive tests actually. So I am going into the statistical analysis only, where we discussed about the frequency, probability and return period. With these probability and return period, these are the two things which I talk. So probability, return period. So and relation I know it. So return period is equal to 1 by probability. So knowing this, how to really play or how to solve different problems there. So what are the important points? Probability of occurring an event in a year. It is nothing but 1 by t, where t is the return period. Very simple. Probability of not occurring an event. It is nothing but q is equal to 1 minus p. 1 minus p means what I can write? 1 minus 1 by t. Please remember. Then probability of not occurring an event r times in a year. Factorial n by factorial r into factorial n minus r into p to the power of r q to the power of n minus r. So that is what I have put it. Factorial n divided by factorial n minus r into factorial r p to the power of r q to the power of n minus r. If you do it, it is r times in a year. That means not occurring r times in a year. Probability of not occurring an event continuously for n successive years. Not occurring means immediately q should come into picture actually. So it is q to the power of n. Probability of occurring an event at least once in a year or once in n years. Probability of occurring once in a year is 1 by t. Probability of occurring an event once in n years is 1 minus q to the power of n. So p is equal to q by t. Q is nothing but 1 minus p, and it is equal to 1 minus 1 by t. So based on this, I have seen many of the competitive exams, number of times the questions have come. If you know these 6 important points, you can answer any of the things very confidently. First thing is probability of occurring an event is equal to 1 by t. Probability of not occurring an event is equal to 1 minus p, that is equal to 1 minus 1 by t. Probability of not occurring an event r times in a year is factorial n by factorial r into factorial n minus r into p to the power of r q to the power of n minus r. P is the probability of occurrence, whereas Q is basically 1 minus P. That's all. Then probability of not occurring basically an event continuously up to n years or up to n successive years, Q to the power of n. Probability of occurring an event at least once in n years is 1 minus Q to the power of n. So these are the important things. So how to calculate the return periods? Let me show with an example. So now I have given they have given me 9 years of rainfall data, 9 years of flood data. What is the maximum flood that has occurred in 9 years? So like this. What I am supposed to do if I want to find return periods? First I will see that I rank them in such a way that the maximum is at the top. Not it is year wise. I put maximum. What is the maximum of all the things? 130 is the maximum if you see. Then 120, 100, 80, 75, 70, 60, 50. Now the first one, highest one is ranked as 1 and the lowest one is ranked as 9. So this is very important for me. M is how much actually? T is equal to n plus 1 by m. Please note it. So if it is n plus 1 by m, n plus 1 by m, so 2.5 years. N plus 1 by m, 2 years. N plus 1 by m, 1.2. So this please again correct it. It is n plus 1 by m. So with this we have completed how to calculate return periods also, how to estimate the probabilities, how to estimate the risks also. We have done it. And in the last thing, so instead of intensity, duration, frequency curves, we have another curve actually, depth, area, frequency. So that means what is the relation between depth and area for a given return period? Frequency means return period. So if you plot depth versus area on x-axis, depth on y-axis, if you plot it actually, so this is how you will get it. Duration, depth for different rainfalls. Once again, so here depth, area, frequency, that is the DAF curves. So DAF curves also we have plotted here. So here what we are doing is, for a fixed frequency, the depth decreases as area increases. Depth increases as frequency increases for a fixed area. So this area of depth, area, frequency, that we will use it for basically for mainly drainage systems, reservoirs, drainage systems, dams, and basically urban hydrology for managing the runoff. This completes to me another curve, and this is how depth, duration, frequency. Depth, duration, this is for return period. Frequency means return period. So depth, duration, frequency. So this is another curve that which we have actually. This completes to me this topic actually.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.